Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 773. Page 773, please turn to it. And today is our lesson number 94. Let's take a look at it. Number 15. The first problem, very first problem in the first column, number 15. It says, the Acme Plumbing Company will send a team of 3 plumbers to work on a certain job. Alright. The company has 4 experienced plumbers and 4 trainees. Alright. So here's our experienced plumbers. Let's give them name. Let's christen them. Let's give them name. Christen is the word that we learn on day number 63. Christen metaphorically means to give somebody or something a name. Christen, of course, literally means to baptize somebody. Let's give them name so that we can talk about them. Let's call these plumbers P, Q, R, S. Why not? I feel pretty lovey-dovey today. These are very endearing terms. P, Q, R, S. And 4 trainees. All right. So here are trainees. If I know how to spell it, trainees. And let's call them A, B, C, and D. If team consists of 1 experienced plumber and 2 trainees, how many different such teams are possible? All right. So before we worry about forming a team, let's ask ourselves how many pairs of trainees we can have out of 4, and then we'll worry about hooking them up with the plumbers. Okay. So we have 4 of them here: A, B, C, and D. Let's find out how many pairs we can form, because we need to send 2 trainees on a job along with 1 experienced plumber. Okay. Let's send a team of 3, the mentor and the 2 trainees. The mentors and the 2 proteges. So we can have AB, that's the 1 pair of 2 trainees, or we can have AC, that's another pair, or we can have AD, that's 1 more pair. That takes care of A. Now once we have paired A with B, then we're not going to count B and A as a different pair, it's the same pair. So now we can have, so we're done with A. Also we can have BC, we can send Mr. B with Mr. C, or we can send Mr. B with Mr. D. Mr. B with Mr. D. And finally, we can send Mr. C with Mr. D. There are 6 pairs. There are 6 pairs. There are 6 pairs of trainees for us to choose from. And there are 4 plumbers. That's all. So 6 pairs and 4 plumbers. Obviously, 6 pairs and 4 plumbers. Let's do it on the top. Where's my... We have 6 pairs of trainees and 4 plumbers to hook them up with, and therefore we have 24 ways that we can combine these people. That's all. The answer is there are 24 ways we can send our team out. When we are scheduling them, when we're putting them in the schedule, there are 24 different possibilities. Number 16. Number 16. We're done with this one. That's it. In number 16, we are given a donut which looks kind of yummy, but unfortunately it's not drawn to scale. I always prefer to have donuts drawn to scale. The picture above consists of 2 circles that have the same center, obviously. If the shaded area is 64 pi, so the shaded area is 64 pi, we are told. This is the shaded area, obviously, the ring. And the smaller circle has a radius of 6. and the smaller circle has radius of 6. Well, if it has a radius of 6, we can figure out the area of the small circle, the inside circle. We can figure out the area of this guy. The area of the small circle would be pi r squared. I'm going to change my marker. For some strange reason, this marker all of a sudden decided to act up. Pi r squared, pi times r squared, which we know is 6. So 6 squared is 36. So it's 36 pi, which is the area of the small circle. We also know that the area of the shaded region is 64 pi, and we just found out that the area of the small circle is 36 pi. It's 36 pi. Therefore, the total area must be 100 pi. Let's see what they're looking for. What is the radius in inches of the large circle? But there we go. Now we know that the total area is 100 pi, and area, so here's the area of the large circle, which we know is 100 pi, which is same as pi r squared, which tells us that r squared must equal 100. If r squared equals, this implies that r squared must equal 100, which tells us that the radius of the large circle must be 10. Radius of the large circle is 10, radius of the small circle is 6, which is why the area of the small circle was 36 pi, and plus the fact that we were told that the shaded region, the ring, is 64 pi plus the 36 pi, giving us a total of 100 pi, which equals pi r squared. Therefore, r squared is 100, r is 10. The radius of the large circle is 10. I will see you tomorrow, okay? Bye now.